Hi, greetings of the day. Welcome to my channel AI. My name is Vidya. I'm a cloud and AI architect, a passionate technologist too. Today we'll learn about ways to create REST API from scratch with a use case. Consider a case where you're required to create a website for hosting a bunch of machine learning or deep learning models for deployment on the Kubernetes cluster. This will require you to create a bunch of REST APIs and microservices. So, to begin with, we shall create simple REST API services that will perform some basic functions as to create and retrieve the results of AI models into the application framework. Let us now understand a little bit about REST APIs. REST APIs aren't new. It has been evolving from so-called remote procedure calls in 1980 towards REST in 2000 and GraphQL in 2015. To put in simple words, the fundamental concept behind REST API is to build services that does not perform all the functions but performs the required function by fetching data from various locations and various function calls. In the pictorial representation given here, you can see a request made from the client to the REST API on the server. On receipt of the request, it gets processed and the response is granted to the client with the desired execution of the task with the desired results. Let's now get started with coding Golang, as Golang is a flavor of Kubernetes native development. It's okay if you aren't familiar with Golang, as we will learn them on the run. Now, I'm going to create a simple REST API with API path /apps v1 samples over two methods or verbs get, add, post across a single resource. The data for samples will be stored in the local cache and we shall store or fetch them as is. To begin with, we'll create the Go module samples. Okay, we are done and we have the Go mod. So Go mod looks like this. Okay, all set. We invoke the Go file. Okay, we'll declare the main package. Packages in Go programming are essentially for organizing files and for compartmentalization of the Go application features. So I'll just go ahead and create Go package main. Let's import some packages. FMT. FMT is for using logging functionality, the printf statements essentially. I'll also pull in OS. We will use OS for grabbing the environment variable. Declare function main, which is the entry point for the application. And then now we define the constant, which is the endpoint. So I'm just going to hardcode constant. API path, I had mentioned earlier, it will be API /v1/samples. We also attempt to fetch the API path from the environment variables, which is why we have pulled in the OS package. Now if API path is available in the environment, we pull it into variable API path. If it's not available, we take it directly from the constant. At this point of time, we can go ahead and save it. Attempt building. FMT is not used. Fine. Remove it for now or comment it. Build again. API path is not defined. All set. So far, so good. So before we proceed further, we go ahead and build the cache into which the data is stored and retrieved. To build the cache, we'll define a structure. So type sample struct. The parameters for the cache and definition into the structure will go something like this. We'll have the name, be string, that will be passed into the endpoint, in JSON. We'll have a model definition that's also going to be string. The framework of the sample will again be JSON. I have the part, double quote here, double quote here, framework. Okay, and finally the programming language string. We're essentially going to store the models into the local cache. Okay, we have defined the structure, basically the cache. Further, we call upon the cache. So we just create a list and dump the data into it. So we'll have one or two entries over there, so we're able to retrieve them when we invoke the REST API endpoint with get method. Mini YOLO will be the name of the sample. YOLO will be the model. The framework will be PyTorch. And then programming language can be Python. Okay, we are done with one entry. Let's go ahead and add one more entry. Let's say we have a Ergo app. The deep learning model using TensorFlow written in C++. Okay, we have two entries in the cache. Save it now. I'll remove the binary that just got created. Just go ahead and build it again to see if everything is okay so that we are checkpointing whatever has been written or built as of now. Line 21. Okay, we have the cache now. All set. With this basic setup, now we go ahead and create a handler for our REST API using the routers. For this, we use Gorilla Mux package from the Gorilla Web Toolkit. Gorilla is a web toolkit for Go programming languages comprises of multiple packages. Other packages included are Gorilla RPC and Gorilla WebSocket. It also provides simple ways to create HTTP routers. Using this package, now we can redirect the flow of the respective HTTP handler accordingly. If you're wondering why Gorilla Mux is called Mux, the name is derived from the HTTP request multiplexer. Now we go ahead and create an instance of route with the Go multiplexer. Route equal to mux dot new router. For the mux definition, we go ahead and import the Gorilla Mux package. Further, we also define the HTTP handler for the GET request. Route dot handle func on the API path we define the function example on methods get. And then we access the same about 80 on the mux instance. We save this further, go ahead and build. Okay, now that we need to do Let's get the mux package. Good. We build again. Okay. Mux.new route. We have the router. We need to define get sample. We then have the HTTP package missing. Let's go ahead and add that. Next time, HTTP. Okay. Third is the get sample function, which is missing. We will now write the get sample function and call the print function when we hit the endpoint. The signature or the parameters that we take here will be the writer HTTP dot response writer and the reader for the request. We save it again. Build. This has to be writer. And now we go ahead and uncomment fmt package since we are using it. Okay, there's an error here. The second parameter. Okay, it's now turned. We are all set with the get method implementation. We could also go ahead and print all the samples available in the cache when the get method is hit. We save it, build again. Okay, we are good to invoke the endpoint on get method either from Postman or from curl. Now that we have created the application, we go ahead and invoke the same. While this is running, we go further and open up Postman to kick off the request on localhost at port 8080, where we are listening on the endpoint APIs /v1-subs. Let's now hit. We have 200 OK. And see the results here. The function getSample has been hit and corresponding log has been made heading sample followed by the entries in the cache as you see here. Mini YOLO and Ergo app dumped across the console as defined in the cache here. In the next session, we will see the implementation of the post method. Thanks for watching. Until then, we are signing off.